Okay, welcome back everyone. This is where we left off a moment ago. We were looking at the embed element. Now we'll look at the new audio element that was introduced in HTML5. Uh, we did see this last week. The HTML5 audio element allows us to play sounds through the browser. It is supported by all the modern browsers. The audio element has various attributes to control its behavior, such as whether or not to show the sound controls, whether to autoplay, to play the sound a set amount of times, or to have the sound play indefinitely, etc. So you can see the attributes listed here on this page. Using the audio element, developers can provide sound content without the need for extra plugins. The most popular audio file types, MP3, WAV, and OGG. Now this table is a bit out of date. I need to update it. I know my Firefox browser that supports MP3 files, so I'm going to need to look into this and update it. But these are indeed the most popular audio file types. Um, in conjunction with the audio element, the source element may be used to specify multiple media resources. The source tag allows you to specify alternative audio files which the browser may choose from based on its media type or codec support. Okay. I know we've seen this before, so basically we're telling the browser here, check and see if you can play this OGG file. If it doesn't understand this request, it's going to look in the next one in which we're saying, okay, if you can't play the OGG, try the MP3. If that doesn't work either, then display this comment to the user in the browser. So your browser does not support the audio element. Downloading versus streaming. We discussed this in the previous video. There's two ways to deliver the sound file. You can download it, which means you download the complete file and then play it, or you can stream it. So you listen in real time. You use streaming when you present live events, when the sound requires very large files, or when you need to save time and you don't want your user to be waiting on the file to download. When you download a media file, a copy of the file resides on the computer's hard drive, and you can listen to it or watch it anytime, or you can even copy the file and share it. When you stream it, the computer does not save a copy of the media file. It only saves enough in a buffer, which is really just the computer memory, to keep the playback in the browser smooth and continuous. You cannot save the media file, burn it, share it, or take it with you. And this is the principle of streaming being illustrated here on this slide. In the bottom left corner here, you can see this video being streamed. The gray part of the line illustrates how much has been buffered. So this has been preloaded in memory and it's ready to play. You don't need the internet connection for this part anymore. The red part is the one that has already been played and completed. Streaming allows you for the delivery of high impact, engaging, and often interactive content. It's typically very flexible and can be distributed widely in a variety of formats. Standard video and audio content can be too large to deliver via traditional formats, and streaming formats offer an excellent compression and very effective delivery. Streaming media, whether it's audio or video, begins playing almost immediately after the request is made to the server and continues playing as the audio and video data is being transferred to the browser. The streaming media technology has been developed to address the problem of unacceptable download times for multimedia files. It's good for broadcasting live events such as concerts or football games, for example, webcasts, webinars, and things like that. So this here is an example of a live webcast. What do the different streaming formats do? There are a number of different file formats for streaming media. Each format uses a different algorithm for compressing and embedding the streaming data. Different manufacturers place emphasis on different aspects of the multimedia: video, sound, speed, bandwidth, for their own format. Because of the competitiveness of the different manufacturers, each format represents a different means of achieving effective multimedia streaming. Common to virtually all the streaming formats is the MPEG compression algorithm, or Moving Picture Experts Group. They develop standards for the compression of both video and audio, digital video and audio. And the actual compression and decompression software is referred to as codec, encoder, and decoder. Um, the pseudo and genuine types of streaming that you see on this slide here, what's the difference between the two? Pseudo is also known as progressive streaming. It's a form of downloading, but it allows for immediate playback. The sound file plays while it's being downloaded. So pseudo streaming uses only pre-compressed data. Genuine, or also known as true streaming, requires specialized server software and can compress the data on the fly, delivering content in a very efficient format. So genuine streaming relies on this special type of server software that permits the uninterrupted flow of data. It uses a protocol called RTSP, real-time streaming protocol. It does not use HTTP. So far we've talked about HTTP only for transferring content from the server to the client. Well, today we're mentioning also RTSP, real-time streaming protocol. Permits a two-way conversation between the server and the browser player. The browser user can request from the server content from the middle of a file, um, for example, seeking ahead in long content, or begin playing from the middle of an audio or a video stream. With pseudo streaming, deploying streaming media content with the standard web server approach is actually only a small evolutionary step away from the download and play model. With pseudo streaming, the audio begins playing before it has completely downloaded, producing a streaming effect even when the file is served from a standard web server. The advantage to pseudo streaming is that it requires no special streaming server. The audio or video files are placed on a standard web server and linked to from a web page by the standard method. There is one big drawback to pseudo streaming because the file is being downloaded from a web server using the HTTP protocol. The user cannot skip ahead to a point, say 14 minutes into the stream. You cannot do that with pseudo streaming. To allow this kind of interaction, we must use genuine streaming. An actual streaming media server must be used instead of the normal web server to provide this kind of streaming. What are the limitations on streaming types? Because video and audio data type can be quite large, compression is an integral part of streaming. With pseudo streaming, we use pre-compressed files, and it only allows users to view the streamed media sequentially. You cannot skip to a set point in the stream. With genuine streaming, it allows the user to navigate to any point in the stream, but it requires a dedicated server software to do this. So genuine streaming files must be prepared specially for delivery. It uses meta files. Okay, it makes use of meta files. When you click on a link for a streaming media file, you're actually clicking on a link to a so-called meta file, which is then sent by the web server to the browser. The meta files contain a set of instructions, or just a URL, that tells the streaming media player in the browser how to connect to the actual streaming server to stream the requested file. Okay, the streaming server may be located separately from the web server itself. And you can see here the process being illustrated. This is with the meta files, and this is basically what true streaming refers to. And that wraps up our discussion on audio. Now we move on to video. Advantages and disadvantages of using video. Video adds a visual impact to web pages. Some of the advantages include you can capture interest, you can increase users' memory retention, you can clarify complex physical actions and relationships with the help of video. Some of the disadvantages, it's relatively expensive in terms of both time and effort to produce. It requires extensive computer processing, memory, and storage. How do we add video to the HTML document? Well, of course, just like with the audio, we can use a simple link, the ahref. Um, the downloadable video files, which could be AV, MPEG, Windows Media, QuickTime, they can be linked to HTML documents using just the standard anchor element. When the user clicks on the link, the browser looks at the type and launches an external player application in a new window, or uses a browser plugin to play the movie in the browser window. Embedding video in a web page, well, the options are exactly the same as for sound. Here's an example. We got the object, we got the param, we got the embed. We discussed this at great length when we talked about audio. Okay, you can when you watch this video on your own, as I've given you the link, you can do that at your own leisure. You can pause the video and examine these in some more detail, or you can try them out on your own if you like. The embed element may be used to embed video in a web page, much the same as with audio. So the syntax is just embed. The video element is very similar to the audio HTML element, only delivering video rather than audio. So that's the main difference between the two. Well, one additional attribute for the video element is the poster. You see down here in the middle. It allows you to specify a URL of an image you want to display while the video is being downloaded. Okay. The video tag is supported by all the modern browsers. Internet Explorer, the latest versions of Explorer, Firefox, Opera, Chrome, and Safari. Using the video element, one of HTML5's many interesting features is the ability to embed videos within a website without the need for additional plugins, such as Adobe Flash. The three main types of video files: MP4, WebM, that's Google's format, and OGG. Again, the table here, my guess is that it's a little bit outdated and I need to verify some of these. In particular, I would start with Firefox supporting MP4. But this just gives you a pretty good idea of, well, one, what kinds of formats we have, and two, the kind of support that they have from the different browsers. In conjunction with the video element, the source element, just like with audio, may be specified, may be used to specify multiple media resources. It allows you to basically identify alternative video files which the browser may choose from based on its media type or codec support. This is the kind of code we've already seen. So in simple English, we're asking the browser, please find and load and play this MP4 file. If the browser doesn't understand this command, it's going to try the next one, which is load the OGG file. If that doesn't work either, then this particular browser does not support the video tag. As with audio, we have the option of simply linking a video to the web page for download and playback, or choosing from a number of streaming technologies. Many of the principles for developing and delivering video content for the web are the same as those for audio. In fact, some of the file formats are the same as well. QuickTime, Windows Media. Like audio, video may be in analog or digital formats. To use video in a multimedia application for the web, it must be in digital form. Okay? Digital video is really a sequence of raster or bitmapped images called frames, displayed in a rapid succession at a constant rate to create the impression of movement. Some characteristics of video: the frame size, it's the width times the height in pixels. For example, 640 by 480 could be the frame size. Frame rate, it's the number of frames displayed per second. For example, it could be between 12 and 30 depending on an application. They say that 24 frames per second is ultimately the minimum in order for the human eye to perceive something as video. You go below that, and the stream becomes really choppy, and people can tell they're not really looking at a video stream. Color depth, it's the number of bits that are used to describe color uh, in pixels. And what we used in our class is the RGB color, 24 bits. That's 3 bytes. Uncompressed video requires many megabytes per second. That's just something that we need to always take into consideration. For example, with digital video, if you got a frame size of 640 by 480 and using 24-bit color, and you're displaying that at 30 frames per second, you're going to need about 22 megabytes per second. That's about 1.3 gigabytes per minute of video. So this becomes, if you are streaming this over the internet, this is going to could easily become a problem. So you're basically asking all of your users to have really great bandwidth so you can handle that kind of stream. You could do something like this from a CD, but you really don't want to do it over the internet. So you got to make choices. You got to optimize your video somehow. You need to make two major decisions about how to present video on the web. Number one, it's the format. Do you want to present your media in QuickTime, Windows Media, or some other format? Each format has its own strengths and weaknesses. Flash used to be probably the most popular standard until recently. Compression methods. Once you have chosen the format, you'll need to decide how much to compress the video. So the more you compress it, the smaller the file size will be, and the easier it will be for users with slow internet connections to access the video. Most compression schemes, however, are lossy. MPEG, the most popular video file type, uses such a compression scheme. It uses a complicated algorithm that removes data for sound and image detail that is not discernible to the human ear or eye. So video is basically the same as a still image or picture, although in video you've got lots of images. Okay. So video data contains spatial and temporal compressions. How does video compression work? Within each frame you can have spatial compression, and between the frames you can have temporal compression. What's the difference between the two? Spatial treats each frame as an independent image. You compress each frame individually. It uses the same techniques as the JPEG image compression. Temporal saves all information for selected frames only. They're called keyframes. Keyframes are usually selected to be about 3 seconds apart. For all the other frames, you only save the differences from the previous keyframe. This is good. It works well when the difference between the current frame and the keyframe is really small. So the keyframes are used as masters against which the subsequent frames are compared. Okay. Let me show you this. This is an example of how keyframes work. Videos without a lot of motion, such as talking head clips, take the best advantage of this kind of temporal compression. Videos with pans and other motion are compressed less efficiently though. as you might imagine. Okay, video codecs. There's a number of codecs, compression and decompression algorithms that can be used to compress video files for the web. Many of these codecs can be applied to several different file formats. And video, like audio on a web page, may be delivered over a network either as a downloaded file, a streamed file, or a progressive download. When the video is streamed, it is played as it arrives. So streaming allows it allows live video broadcasts, but it requires sufficient bandwidth to deliver the video frames fast enough to be played. Progressive download means that the video starts playing when the time taken to download the remaining frames of the video is less than the time it will take to play the whole video. And it's good to note that the popularity and the power of the Flash browser plugin and the standalone Flash player made Flash an alternative to custom players and interactive media. However, HTML5 and CSS3 have features that provide an alternative to Flash. And Adobe, the company that supported Flash, um, have stopped supporting it in favor of HTML5 and CSS3. How do you transfer the video on the web? There's two types of transfer we mentioned. HTTP, the Hypertext Transfer Protocol, it's used to download the video from the host, the server, to the user's computer in its entirety before playing it. And then RTSP, the real-time streaming protocol, is used to play in real time on the user's computer in a process called streaming. RTSP allows the user to perform tasks such as pause and play. Videos may be downloaded via HTTP or streamed. There's a number of streaming server software packages, QuickTime, Windows Media, Flash streaming servers. Um, you can find quite a few of these available on the web. As in audio, streaming video is added to web pages via linked or embedded reference files, also known as meta files. And the process is exactly the same both for video and audio. Okay. Viewing videos on the web. Okay, so just one final quick summary. Files may be downloaded to the user's computer and only then begin to play. Characteristic of these is you could be dealing with large files and long wait times. Progressive download. A click begins the download, but after some portion had been downloaded, the movie would start to play. The player, for example, Windows Media Player, calculates the speed of the download and guesses when to start playing the portion it has. The plan is to start late enough that the whole movie will be downloaded by the time you finish watching it. And finally, true streaming. The file is not downloaded at all. Media begins to play as soon as it gets the first packets of video data. This is the fastest type of video playback, but it requires that the server be set up to serve streaming media. It reduces the waiting time required of the user, and the drawback of this is congestion on the internet may cause the media to stall if the downloading process cannot keep up with the playback process. Alright, and that wraps up our discussion on multimedia in HTML5. What we saw in these last couple of videos are how we create image maps, how we can load and play audio files, and how we can load and play video files. Thank you for joining me today. Have a great day.